Today we're talking about inverse functions. And so here's sort of what inverse means is opposite. I guess that's kind of what I want you to think in your head when you think inverse. So I'm just going to give this to you. Take a look. If you're going to find an inverse of an ordered pair, just switch the x and the y. And there's a reason for this, and I really am hoping that you figure out the reason to this in a minute. But so here's the x, here's the y, you know that. And so if I'm going to find the inverse of that pair, I'm just going to switch them. And that's it. All right, so far so good. So now we get to an equation. And for this equation, I want to find the inverse of this linear function. And so when I do that, I'm going to follow that same idea. I'm going to switch the x and the y. That's the first step. So if you want to write a procedure down, your very first step would be to switch x and y. So that's what we're going to do first. Literally, I'm just putting the x where the y is and the y where the x is. So I'm going to have x equals 3 times y plus 5. Then I'm going to solve for y. Solve for y. You can make sound effects while you're doing this. I find that it helps a lot. All right, so we get that. Every single one of you should be able to solve for y at that point. And so I'm going to use different notation just so you're familiar with the inverse notation. So instead of y, I'm actually going to look at this as f of x because this is a function of x. And so when I get my result, I'm not going to set equal to y because it's almost like, okay, well, I started with y and those aren't the same thing. So instead, I'm going to use this inverse notation, which is, it kind of looks like you're raising f to the -1 power, but you're not. This is just the inverse notation. And so the way I would say this is f inverse of x. And so it's this function right here, which is also a linear equation. Graph of a line. And so we're going to go ahead and look at this graph along with its original function. So go ahead and open your calculators and put it in for y1 and y2. Lucky for me, I know about that fraction option, and so I can just do that very easily in the calculator. You should know it too. So I'm going to look at this graph, but I want to look at it in a very particular screen. And so can you go to Zoom? I hope you're doing this and not just watching. Do it. Don't make me do all the work. And I'm going to go to Zoom Square. And that just kind of like squares up the window and so we can see what I'm going to try to show you a little bit better. So the line that's in blue, that's our original equation. And the line in red is the inverse of that equation. And it turns out that if you have a function and it's inverse, you will always, always, always see this sort of reflection, and it's a reflection through a very particular line. And since I don't have you here with me, I'm going to go ahead and tell you, and then we're certainly going to talk about this more in class. The line that it gets reflected through is y equals x. So I'm going to graph that line too. Back to y equals x. And hopefully you're familiar with this line, but it's just a line that sort of goes at a 45-degree angle through the origin. And so when you have an inverse and the original equation, you're always going to see this reflection through the line y equals x. And so that's the main idea I want you to take away from this video, is that y equals x is kind of the main idea. So when you're finding the inverse, we're going to switch x and y and then solve for y. That's the procedure. But just to kind of show you this reflection here, we can see that on the y-axis, it has a y-intercept of 5. And then on the inverse function, the inverse has an x-intercept of 5. So another kind of cool thing, well, I think it's cool anyway, is I want to show you something in the table of values. Second graph. And we're going to kind of look at the table of values, and I think that, oh, bummer. You can't really see what I was going to show you. Just kidding. But we'll certainly talk about ordered pairs because it's kind of a cool thing with graphs and their inverses. So just kidding on that one. Here's an example for you to try. And this is a little bit more involved, but the procedure is the same. So go ahead and rewind if you need that procedure, or look in your notebooks because it should be in there. All right, thanks. We'll talk about this in class.